Okay, yay. So for people who are seeing the recorded version, this is the Boston and Indy joint AWS meetup. And we're still letting people in. And we are very, very pleased to have Chris giving a talk that I titled An AWS Hero Gets Weird. So, so Chris, take it away.
Okay, great. Thank you, everyone. Thanks for having me. I guess one thing I'd like to start with is just so that I kind of understand, the audience and what your experience is. Of course, I can't see you all, but so how many of you are familiar with machine learning and AI? Do you work with it? A few yays. How about DeepBlaster? Okay, all right. Well, that's good to know. Okay, awesome. So my name's Chris Miller, and I have a company called Cloud Brigade out in Santa Cruz, California, and we are 16 years old. We do consulting around Linux and open source, and about 2014 or so, we got into AWS kind of basic building blocks, and about 2 years ago, got into AI and ML. So we're kind of leaning into the revolution, and yeah, as a business owner, it sounds a lot more glamorous than it is. We're a pretty small team here, and but we have a lot of fun geeking out on tech stuff. So, live in Santa Cruz. I've worked in tech for 25 years. Call myself a geek with social skills. On the West Coast out here, I got the ocean, so we're doing the paddle boarding and ocean swimming, and I got an e-bike most recently, and that's a lot of fun, especially as I've been getting older. And deep racing, which I got exposed to at the Santa Clara Summit in 2019. And I came in and almost accidentally won the race in the last hour of the event, and got swooped away and a camera put in my face, and it was all very crazy. And so that was a picture after the event. So I got recruited into the AWS Community Builder program in their early beta. And this is a program that you can apply for. So if you use AWS technology, you enjoy writing about it, sharing knowledge, helping others, I would encourage you to apply. They have a application window that opens up every 6 months. I think one just closed about 2 months ago, but keep your eye on it. There's a private Slack channel. It's a great community. I've already collaborated with some people around the globe on fun projects. And that's great. And, I don't work for AWS. Nobody's paying me to say it. I'm just saying one geek to another. It's been a really cool community. And I was just recently selected to be an AWS Machine Learning Hero. And that was how I met Brian. And so, yeah, I'm just having a lot of fun. This is just a great time to be working with this technology, and a great time to be broadening my network and working with other people. And yeah, I'm just having the time of my life right now. So about me, I'm kind of a crazy idea guy. This is a cardboard boat that we entered into a race a few years ago, which I extremely overbuilt. But apparently it holds 900 pounds because I was asked to do the victory lap with some of our young developers in there. So it's got 900-pound weight capacity. This is, speaking of Futurama, one of my favorite shows. I built this Bender costume, and over time added servo-controlled eyeballs and a MP3 of Bender sayings and stuff, so I could go into a bar and say, "Bite my shiny metal ass," in Bender's voice himself. This is a local hackathon that started in 2011, maybe 2009. We built a proof of concept microbrewery, and so it's a Linux controlled. It has a LabJack, which is a really inexpensive data acquisition and control system over USB. when I was anti-Linux, I did try to write a device driver for FreeBSD, but finally gave up. And I think that was when I said, okay, I'm just going to embrace Linux. And yeah, a fun experience with that. Let's see, next slide. And the Poopinator. So one of my first forays into doing computer vision after working with DeepRacer was the Deep Lens device, and so I got to talking with the product team and got my hands on one of these things, and I had gone to the end of my driveway at night, taking the garbage cans down as I hated to do, and came back in the house and I kind of got a whiff of poo. And I thought, man, I wonder if we could train this camera to detect dogs, but only when they're pooping. And it turned out I was right. So we did this silly project for fun. This is an engineer of ours, Ben, on the left side of the video there. And came in and I said, hey, I want you to train a computer vision model that detects dogs pooping. Away he went and started building a model. And we found out that a guy in our business community really needed this solution. So we staged it up at his house, and I built an Arduino controller to turn on a sprinkler whenever it detected a dog pooping. And AWS caught wind of this, and they said, well, we want to hire a video production company to make a video about this and promote you using AWS technology and stopping pooping dogs from going on lawns. And I'm as shocked as you are, but I think it was kind of, being onto something. I'm the crazy idea guy, and that actually resonates. So I am just going with it. Oh, I'm gonna skip the video for now. What is DeepRacer? It is a toy car. It's a four-wheel drive truck chassis. And Amazon worked out some agreement with a company that makes a lot of these, and they removed the RC controls and they put a Intel-based computer node on top of it. And it has two servo outputs, one for steering and one for the throttle. And the reason behind this is that, technically I'm a software developer. Normally I run the company, but I found it intimidating, the thought of learning machine learning. We have kids that would come in. We do a lot of like internships with students from the local colleges, and they get these geeky, software developer kids that have taken these classes, all this theory and going on about machine learning. And I'm like, man, that just makes my head hurt. I'm not dumb with math, but it's not my favorite thing. And so it was just always something I kind of held at bay. And when I got into the summit class, the summit session on DeepRacer, it was a 2-hour session. It was hands-on, and there was just a stub of Python code that I had to edit. And I was a mechanic for 10 years, so a lot of the settings, the knobs that you could turn on the environment had to do with the car steering and everything. So I kind of put my mechanic hat on for that. But the reward function is really simple. It's about 20 lines of Python code to start with, and made some tweaks to the code, and my model worked really well in the virtual world. And they said, hey, go down to the expo floor. There's a real racetrack with cars. Here's a USB drive. Just load your model on there. And it was surreal going out there and watching my car go around the track perfectly the first time and not again. It couldn't complete a lap after that. And it fastest time of the day, just blew my mind. And I was bit, and I realized, hey, this isn't as intimidating as I thought it was. And what I found through my own machine learning journey is just keep showing up. The terminology is going to start to set in. It's going to make sense. And I'm not all knowing about all the different facets of the different kinds of data science that you can do. But the more I show up, the more I learn. And I'm actually working on my AWS machine learning specialty certification. I'm going through some additional training, and so I hope to get that cert this year. So, I'm kind of a regular guy, and so I would say if you're at all interested in this, like, go for it. Just show up, and you'll start learning. And the point of Deep Racer is to lower that barrier or to eliminate it for software developers like us to learn machine learning. And
Chris, can I ask you, what was your time for
oh, it was like 10.2 seconds.
Okay, that's really awesome, because I played with the Deep Racer and I managed to get the lap time down to like 22 seconds.
Yeah, it was crazy. And then that was the first summit. And by the time they got to Singapore, there were people getting 9s and maybe even 8s. And
Yeah.
these were like, I mean, the people who won the reInvent race, they were all data scientists, and they weren't playing with the console, like the abstracted console in AWS. They're in SageMaker notebooks and they're doing real data science to improve their times, figuring out how to make the car go in the shortest distance possible. So like going straight through turns to the degree that they could, because shorter distance means faster lap time. And yeah, it really showed. And so if I hadn't have gone to the first summit in Santa Clara, like I probably wouldn't be here talking about it. So it was cool to be the first one. Yeah, and so you can compete with Deep Racer. You get 10 free hours in the AWS console when you turn it on, and you train models, and then you can submit them to virtual races. And if you get a good enough time, they'll send you to reInvent. So and they did for me. That's like, wow, I'm going to reInvent. I can't believe it. Okay, so this is a slide from Andy Jassy introducing this back in 2018. So it's just a nice slide that kind of shows you what the car is about. I think it's kind of an ugly car, only because they put the camera on the front of it, so it made it very tall, and so it's what it lacks in sex appeal, it makes up for in technology and geekiness. And they recently open sourced this. So let's see here. I'll just play this clip. I don't know how well I'll play over Zoom, but this is me at the 2019 summit, and that was my car training itself to drive. And it literally just starts crashing into walls, and then it through a number of episodes begins to learn like, hey, I get a reward every time I stay on the track. It's kind of like training a dog to do a trick. If the dog does a trick you ask it to, you throw the dog a biscuit, it's happy. If the dog doesn't do the trick, you don't give him a biscuit, and the dog's not so happy. So yeah, like I said, the environment kind of dumbs down and abstracts the data science so that it's usable, that it's approachable. And so you can do a lot in there. And it's based off of reinforcement learning, which is this reward-based type of system. And Amazon just continues to invest a lot of money into this environment. There are people on the team that are dedicated to running the races and building the environment. And it's been cool to be part of that, giving feedback and whatnot, and being part of the community. So earlier this year, they decided to open source the Deep Racer. And the reason for this is the car is $400 if you get the base model. There's another version with LiDAR and dual cameras. I think it's 600 something. But the car's not usable without a track. I built my own track with the assistance of our local Deep Racer meetup that I started. And it just took tens of hours, and it was about $500 in duct tape and foam blocks and stuff like this. And it was a pain. And I didn't want to go out and buy one of the vinyl tracks because it's, had a little shinier surface. And, I thought I could build a better track myself, and so, but in either case, buying all of this stuff is expensive. You have to set it up in a large area. 17 feet by 26 feet is the dimension of the 2019 track. So Amazon decided that, well, hey, how could the car be used without a track? And that's where Deep Racer open source came in, is that I think somebody's got a mic that's hot with some background noise. Thanks. So they asked a question like, well, what would people do with the car if it wasn't about racing, if you didn't need a track? So they cornered a group of us, about a dozen of us, and went around the room and asked if there were any ideas. And so we started floating ideas around. And I guess I'll take a step back on this. Robot operating system is what the car is based off of, and so it's a series of simultaneously running nodes. It can be C or Python or other languages, and they communicate with each other in near real time using a messaging system. It's kind of like MQTT. One node will subscribe to a topic of interest that it needs to see when certain things happen, and then it can kick stuff off. And yeah, it's a really, really cool system. I had no idea that that was what DeepBracer was using under the hood. But I got to learn the ROS operating system as part of working on a project for Amazon here. And so this will give you an idea of like the number of nodes that are involved here. Like they have a node just for LiDAR. So the LiDAR sensor, spins around and it detects objects, and then when it finds objects, it sends that message to a topic, and other nodes can then pull that information in and then take action based off of that. Already covered this, got a little ahead of myself. So that is a vinyl DeepBracer track and barriers that I had set up down the hall from our office. Unfortunately, that suite is now taken by another business, so I don't even have a place to set the thing up right now. Okay, and this is the stereoscopic vision with the LiDAR. And anyway, getting back to the discussion, they went around the room and were asking us for ideas. Well, like what could you build? And well, we could build a terrifying animatronic toy, or not. This is a project that I started working on a while back. It's an animatronic dummy. This is a real ventriloquism dummy that I got from some kid at the bus stop. True story. It was like doing a drug deal. I handed him a bunch of cash. He handed me a briefcase with this dummy, and I started putting Amazon technology into it. So let's see. So what can you really build? And this is the topic of the discussion. Is one guy said, I want to build a better mousetrap. And so he built a robotic cat to go chase around a mechanical mouse, with the use case of, hey, we could use AI to deal with the rat problem, because that's a big problem. Another guy said, hey, we have the car running around a track doing a race. What if the car knew how to deal with stoplights? Like we could make these little miniature stoplights and turn them red and green, and the car could stop and go. And so he built that out. And the Amazon had these 3 different existing samples that they created: a 3D mapping with the IntelliSense camera, follow the leader example, where the car would identify a person and follow you around the room. And then there was a non-GPS navigation using QR codes. So the car would drive around, see the QR code, and the QR code would instruct it what to do next. So when they came around to me and asked me what I wanted to do, I said, well, why don't we just strap a Nerf blaster on top of the car and drive around and find objects and assimilate them? And again, much to my surprise, AWS said, do you think you can get that done in 2 weeks? Sure, why not? I'll give it a try. Took me closer to 4, and they pushed back the release of the open source initiative to accommodate this project that they hadn't anticipated would use hardware in addition to software. Does anybody have any questions? Maybe I should stop, and before we get into the DeepBlaster part of it, questions around DeepBracer.
Chris, so thank you. One of the things that I had wanted to do and couldn't do because of the whole track thing was I wanted to have a DeepBracer that would meet a interview candidate at the elevator and then lead them to an interview room. And I'm wondering if you could do that with the QR code thing, or maybe have it, detect the person, the receptionist or something, and follow the receptionist to the interview room.
Yeah, I think in terms of identifying a person, you need to have enough images of that person to build a decent model to detect that person, right? So if it's your receptionist, that might be easier because you may have a number of pictures of him or her and permission to build a computer model around that. For a random individual, it might be a little bit more difficult. So you need some way to identify that person. Uh, in terms of navigation, I have not played with the LiDAR part of it. So you could use that kind of like a Roomba to do to not run into things. Um, QR codes might be a way to do it. The servos and the steering in the car, getting, I guess if you had the dotted line, on the ground, that would make it easier for the car to navigate and to steer correctly. But yeah, I'd have to think about how you would deal with navigation through the office without some kind of system feeding it inputs. Like if you had some kind of an inside GPS system, let's say. Um, which is probably maybe that's a more complicated approach than is necessary. I guess with the QR code, if the QR codes were close enough in distance that the camera could always see the next one, then maybe that might be a viable way because the car could then steer towards the QR code. And in your camera, through OpenCV, you get X and Y coordinates of the object that's detected. And that is what you can use as a basis for changing your steering angle so that you're aligning that object with the center of the screen and thus steering straight.
Okay. It's funny, I had all these ideas that involve offices, but which seems kind of moot now. I was also wondering whether you could teach one of these to run around your office, run around the perimeter, and using image recognition, detect a conference room that was open.
With this technology, I would say that probably anything's possible. You just have to jump in and build a model. And certainly there's a process for doing this. I mean, trying to get a bunch of moving pieces to work together um, all at once, that's a lot of work, right? And my experience with DeepRacer was there were a lot of different things going on, like a lot of different subsystems that needed to be built in the process. So if I was going to try to attempt something like that, then the first thing I would do is build a model that determines if a conference room is in use. Is it that the door is open? Is it that the light's on? What constitutes a conference room in use? And then start with being able to solve that problem. And once you have that functioning, then to start uh, doing the other building blocks like, okay, I've got to get the car to be able to navigate around the office. How do I do that? Maybe it's the QR code thing. How frequently does it do the rounds like a security guard? Um, how do you keep the car charged to do this for a long period of time? Because at that point, the battery is going to run out, and you could probably borrow from, the Roomba has its own charging station that it can navigate into and get charged up and so forth. But it's like any technical problem that I'm sure we all work on. It's breaking it down into bite-sized chunks and then putting them in the right order and then executing it.
Thank you.
All right, anybody else? All right, well, I'm going to proceed and talk about the DeepBlaster project. So this is a bare bones deep racer with a Nerf style blaster. This is actually made by a guy who goes by the name Out of Darts. And so he is part of this Nerf modding community that I didn't even know existed. And he started 3D printing parts to modify Nerf branded blasters that shoot darts in these little yellow foam balls. And he was so popular that he moved out of the Bay Area to Washington State. He rented a 4,000 square foot warehouse and he filled it with 3D printers, and he has 20 employees, and they cannot print these parts fast enough. And ultimately, he came up with his own idea, Jupiter Blaster, that has a couple of flywheels that spin at about 25,000 RPM and is capable of shooting 15 rounds a second of these little foam Nerf balls. So we didn't need that. I had to figure out how to shoot one round at a time using computer logic. And so that was a bit of a challenge. But my justification for the idea is that, okay, I trained a car to race around a track. Now you've got a lot of people doing this, and the people who are better at it are going to always be in the top position. How can we make the competitions more complex? So what if the car, in addition to having to get around the track with the fastest lap time, also had to have the highest score in terms of blasting foam balls at inanimate objects. I don't know what that looks like. Is it, soda pop cans or something like that? And so your score is a combination of speed and the total targets. So that was the motivation behind the idea. Um, we were able to get our hands on a copy of the LiDAR bracket design file, from which we stripped it down and made a platform just as a foundation, and then we were able to attach that to the car. There's a makerspace next to my office, and I have a subscription there, and so they were really helpful in helping me do this because I haven't really learned how to do all the 3D modeling yet. So I found this model on a website called Thingiverse, where people share open source 3D models. And this is a modified version. Somebody had wanted to put a camera on a turret mounted on top of a toy tank. And so we modified this to be able to put the Jupiter blaster is the name of the blaster, to put it on top there. And that's the Jupiter blaster. And this is close to a complete build here. So the thing sticking out of the back is the magazine that holds 12 or 13 of the foam balls. And I had it almost assembled here, had to do some other electronics. The motors that spin those flywheels pull like 28 amps of current if you happen to jam a foam ball in there and it isn't able to shoot it out. And that will wreak havoc on electronics. So um, I can get into the circuitry another time, but yeah, so I had to learn some new things about electronics to be able to pull this off. So one of the limitations of the Deep Racer platform is that it only has 2 servo ports. They didn't build the compute node in mind for expansion, or I don't think they did. And our Raspberry Pi, on the other hand, has a dozen or more I/O ports that can be used to do run servos and read sensors and control solenoids and stuff like that. So I had tried playing around with the steering servo. I'm like, well, what if I just make the car drive straight and I'll rob the steering servo controller and I'll use that to aim the DeepBlaster. And I tried that for a while and I decided, this just isn't a viable direction. I'm tripping over too many conflicts with the way that the base software was constructed. I really need to break out and build my own node. So that required getting an Arduino, building a servo controller. DeepBlaster right now in its current form, it will aim left and right. But in order to properly aim towards a target accurately, you need to be able to aim up and down, right? Because the target may be at a further distance. You may not have the luxury of getting up close to it before you blast the foam ball. So I wanted it to be expandable, and I got to thinking for other use cases for Deep Racer in the open source capacity. Um, think of like Fukushima when they had the reactor broke open. They had to send a robotic vehicle in there to measure radiation levels because it was too much radiation for a human to tolerate. So I thought, well, maybe somebody might want to build a robot off of DeepBlaster that has a sensor arrays. Or maybe it controls other devices, like maybe the goal is a robotic arm goes and it picks up things and puts them into a bucket, or something like that. So I really put a lot of effort into the Blaster control module, which has its, this is all open source, by the way. So we're github.com/Cloud Brigade, and you can find the repos out there. So I thought, this is a classic giving back to the community, right? Building this extra piece of functionality that other people can leverage to do whatever they wanted to do with Deep Racer. So one of the challenges there is that you have to get the two computers to talk to each other. And the Deep Racer has 5 total USB ports. And so with 2 cameras and a LiDAR and the Intel Neural Compute Stick, which is very useful for doing multiple object detection models, it left 1 port left over. Now, technically, I could have used Wi-Fi or I could have used Bluetooth, but I thought, any kind of Wi-Fi and Bluetooth implementation is just inherently unreliable. I'm sure you can all relate to your headset becoming unpaired, or the difficulty in getting two things to talk, and then when it breaks, it's just a pain. So I thought, no, I want a hardwire connection, but it also meant that I had to establish a serial communication protocol that was pretty robust. Um, so I had to, well, I found open source libraries that I was able to combine together to build a more robust control system. So I'll move on to the next one. Again, I'm getting ahead of myself. Full disclosure, I gave this presentation about a month ago for the New York machine learning group, and it felt very appropriate to reuse this deck. And so I'm kind of jumping around here a little bit, so apologies for that. Okay, so here's what the electronics looks like for the DeepBlaster control. A MOSFET is something that was originally used in high power amplifiers for like electric guitars and music and stuff like that. And it turns out they're very good for controlling high current motors. And yeah, and then I'm not using very many ports on the Arduino, 3 total, 1 for the servo, 1 for each MOSFET. The flywheels spin, and then you use a feeder motor to load the ammo into those motors. So they sell them in different speeds. And so I got the lowest speed was 3 rounds per second. And then I just programmed the Arduino to turn the motor on just long enough to fairly reliably fire one foam ball at a time. Okay, so my work is based off the Follow the Leader project. So Follow the Leader, as I said, it detects a person, and then as the person walks away from the car will follow, and it knows how to follow left, follow right, follow straight. Also knows that if the person goes towards the car, that it will back up, and it can also turn. And so it does this through a series of nodes that, for the most part, I was able to copy existing nodes and then repurpose them for my own uses, which not saying it was easy, but it was certainly great to have a starting point, like a proverbial hello world example that already worked, and I was able to tweak and tune it from there. So there's an existing object detection package, which what I did is, for my demo, is I just use the existing object detection. I settled on a bottle, but I think there's like 50 different types of objects that it can detect. I resisted using the cat model for obvious reasons. The cat wouldn't have been very happy with that. Actually, when the flywheels spun up when I was testing it, my cat just booked because she saw what I was doing, and she's like, "Nope, I don't want any part of that." So yeah, so I used existing object detection model. I forked it because ultimately I would create my own model that would detect something that wasn't provided by that, some neat object that I would put around a Deep Racer track. The targeting controller, this is responsible for getting the X and Y of the detected object and then communicating that to the DeepBlaster control module, or node rather. And this was based off the navigation node. And so the DeepBlaster navigation was tracking the object, feeding those coordinates to the Follow the Leader model to tell the car, do you drive forward? Do you drive backwards? Do you go left and right, and so forth. Now, to control the DeepBlaster control module, the Arduino, I could have built that into the targeting module. But again, in the interest of allowing maximum expandability and freedom, I decided it was best to have a separate node for this. that allow people to build things independent of necessarily needing to tie it to object detection. DeepBlaster interfaces. There is an interfaces module that basically establishes these are the messages and communication that I send back, what to expect an integer or a float or a text string or whatnot. Again, just copied from Amazon, tuned to my own purposes. It also defines services, and services are a way of enabling and disabling, or like to say, arming and disarming the targeting controller, or that kind of thing. And then the launcher is just really a startup script. It is the thing that is responsible for firing up all of the individual ROS nodes, feeding in or overwriting default parameters, and so forth. And I got to say, I had known about the project, but I'd never coded in it. And so it was really a blast jumping in and learning something new and getting something to work like this. So here's a workflow of kind of how the nodes talk to each other. And I'll just pause here for a second. I have a typo on the right side here. The bottom square should be the blaster control module. And you can see the communication thread there. All right, so we're operating on something called an action space. And ultimately, my goal with DeepBlaster was to have two cameras. There's the existing camera that the car is supposed to drive around a track. And then a second one would be mounted on top of the blaster. And the idea here is that, remember I said in OpenCV, you get X and Y coordinates on the object that's detected. And so I wanted the turret to turn until the X and Y got 0 on the object, in which point it would know to fire the foam ball at the object. But due to time constraints, what I had to do was use what I call a static action space. So I use the existing forward-facing camera. I determine what the X and Y is of the object, and then I point the turret in that direction. So it's less accurate, of course, because you're kind of pointing it in the general direction with the hopes that you're going to be able to make contact with the object. But I was able to use the existing action space that was used in the navigation controller with some tweaks, obviously. And this is kind of what that looks like in a spreadsheet when you're kind of mapping these things out. And this is another diagram for that. When I worked with the AWS, the DeepBlaster team on this, what they required was that in addition to writing the code, we had to do all the documentation and in GitHub. And so if you look at our GitHub repositories, that structure is borrowed from the AWS follow the leader example. So it was nice. So some of it was just a massive exercise in search and replace. But I also had to put a lot of specific things in there. And so, as developers, documentation always comes last. And this was one of those cases for sure, but it was a requirement for launch. So, so I had to get it done. All right, so I made some of my points here about why I went with serial communications. And I thought, why reinvent the wheel? Like, I don't need to design my own serial communication protocol. Somebody must have done this before. And I went poking around and I found this robust serial library. And I think it's a kid in France that was competing in a robotic competition. And he created this library that was capable of doing up to 255 commands. There was Python and Arduino examples, and that's great. I needed to use Python on the DeepBlaster, and so that was super helpful. And in the spirit of open source, I want to give credit where credit is due. So to Anton and Raffin, thank you for building robust serial. The second thing that I thought was important is that when you're doing object detection, motion matters. And so abrupt, jerky motion is going to result in blurred video that's not going to be useful to the camera. And you can see these are two strategies in how you can control a servo. And one is fast and jerky, and the other one is very slow, but not fast enough, right? So there had to be some in between. And I knew, like from some experience with a video game project, that you could use math that I don't claim to fully understand to deal with inertia and acceleration and deceleration. And again, not wanting to reinvent the wheel. I found that another smart person, Simon Bluett, created the servo trajectory library. And so it gave us this ability to determine, or to define rather, how fast do I want to accelerate? How fast do I want to decelerate? And although we haven't benefited from this in terms of a camera, I haven't put a camera on there yet, but I built with the intent that this was something I was reasonably certain that we would need. And so I included that in the build. And so the blaster controller module code in the Arduino has munged both of these projects together to give the basis for doing the servo control. So yes, we want to do a dual camera design. The DeepBlaster turret, this is based off a micro servo, and I've already broken one, and I think I've broken two of them. I just haven't turned it back on to see yet. So we're going to do a one-piece 3D printed model with a full-size servo and probably one with metal gears, because that Jupiter Blaster is a lot of weight. In fact, it makes the car squat, and I've got to mess with the suspension to kind of tighten it up. I have communicated with Out of Darts, aka Luke Goodman, and he is making a wearable version, kind of like a wrist-mounted version that should be lighter in weight. And so I'm looking forward to potentially collaborating with him and getting a lighter version of this. Yeah, dynamic action space we talked about, and hit counter. Like, wouldn't it be great if the computer model, the object detection, knows when the object is needs to be acquired and when it has been eliminated. Okay, so I got some links here, and I think next is my thank you slide, so I'll hang here. Does anybody have any questions? Come on, I know somebody has a question.
Do you have a video of it shooting?
Yeah, if you go to cloudbrigade.com/DeepBlaster, I can bring up the video. I just think it's choppy when it goes over Zoom, isn't it? Aren't the frames all?
Give it a try.
Okay.
Zoom's gotten better about that, but yeah.
All right, there's a way I can optimize for that. Hold on one second. Let me stop the share.
I think for me, it's a little overwhelming to absorb all of the pieces that you put together, and to think that you did that in 4 weeks. I'm a little like, that's a
Thank
lot.
you. It was actually, it's one of those, like, I can't believe I just agreed to this, kind of thing. Like, but it's kind of hard not to. I just come up with these crazy ideas, and then I stay up at night. I call it the hamster wheel. Like, my head will just not let go of the idea, and then I'm engineering in my sleep, and then it's like, well, why not? It's obtainable, and then I find out how hard it really is, and then you just keep knocking out the problem. So unfortunately, it meant that I was working even way crazier hours than I'm used to. But hey, we pulled it off. It was a success, and so I think there's a lot to be said, motivation wise, for being able to set a lofty goal and to be able to achieve it. All right, so this is our DeepBlaster page. Everybody see that okay?
Yep.
Okay, so this is a picture of the track that we made, and kind of our early trials. So anyway, here's the DeepBlaster Promo. Oh, do you see it full screen or not?
Not full screen.
Okay. I am going to go over here. Oh, and let me share sound here. Hold on one second. Okay. Oh, and I can optimize for video clip. Great. All right. Can you see it?
Yep.
Okay, great. Let's.
That were hit with the blaster.
Let's build our DeepBlaster. First, install the parts and the blaster itself. Lastly, the blaster controller. Next, we program the blaster controller. Step 3 is to build the ROS packages. Step 4, load your ammo. It never gets old.
It sure looks nasty.
And I love all your steps because each one of those steps is like, oh yeah, and then code the thing. It's like that cartoon of, and then a miracle happens, but it's like step 1, a miracle happens. Step 2, a miracle happens. Step 4, a miracle happens.
Yeah, AWS had asked us to do videos for this, and I'm like, well, wait a minute, I'm barely able to get this code done on time, and then you want me to write documentation. Okay, I get it. Now I have to be a video producer and do this stuff. I complained a little bit, but it was all worth it in the end.
But Chris, when you were talking about the the smooth but slow motion, it made me think. I did a virtual camera project, and it was the one and only time I've used calculus, since getting out of school, and getting the second derivative of acceleration, which is jerk, to like, okay, I'm going to speed up the move and then slow down the move so that there's not a high delta of the delta, but you can still move quickly.
Yeah, I had like I said, we've done a number of internships, and it's not just kids. I mean, I've had people of every age group do internships at our company, and I had a guy working for us. Became great friends with him. Sadly, he passed away a couple of years ago. But just brilliant in math and programming. Went to MIT, and we talked about doing an asteroids JavaScript game, and so I showed him this game that I saw online, and so he took it and made its own. We were doing a kind of WordPress versus Drupal and Joomla kind of thing, and so we used those kind of icons in it. And so when he was writing the game, he was talking to me about exactly this calculus, as I forgot it was calculus, and talking about the problems. And I have not taken calculus, full disclosure, but I'm glad that he figured it out. And again, it's like, this is one of the beauties of open source is, there are lots of smart people, smarter than me, out there writing code, and we're able to borrow from those examples and to pull these pieces in and build our own technology. And without open source, we wouldn't have that. We would not be where we are in tech today.
Absolutely.
Well, here, I got my contact information here. Feel free to reach out if you want to have a chat. Ping me on LinkedIn. I'd love to connect with you. And this is great. This is, I think, one of the first meetups that I've been a local meetup that has actually pulled in people from around the world. So it's really great to see the community that you built here.
Yeah. If I can ask you one more question, and
yeah, I got time.
Yay about Go Community. One idea that I had wanted to try, and I'm not. It seems like Amazon is expanding sort of the bounds of what DeepRacer is allowed to do. But when you had the platform where you have the blaster, I had the thought that for the DeepRacer leagues, everybody is optimizing for speed. But I was wondering about smoothness. So I had the notion of, you put a plastic cup on the top of the DeepRacer, you fill it to the rim, you put in a measured amount of water, and then at the end of the course, you measure how much water has spilled. And it's especially interesting because you're going to spill on your own car. And so you would have to optimize for smoothness.
Yeah, that's a good question. The model, or the reward function rather, that I chose at the summit was one that incentivized the car to steer less. So it would actually get a penalty. So the reward is a 1 or a 0, but you could feed it like, oh, well, if you turn too much, I'm going to reduce your reward to 0.8, and
Right.
it would figure that out. So if you don't use that, the steering is very jerky. Right now, you aren't able to control, well, in standard DeepRacer, you're not able to control the throttle through the AI model. That's all done manually. They give you an app and you set the speed, the throttle to a certain percentage, and you have a stop and a start. But with, I mean, clearly you can do that because the compute node is actually talking to the motor driver, the throttle control. So certainly it's within the possibility that you can set the car into a self-driving mode that includes controlling the throttle. And I would not be surprised at all if DeepRacer League, that you would actually be able to do that in the physical world. Everything went virtual last year, so there wasn't, an actual race. In the virtual world, I believe the car does accelerate and decelerate, but to date, it hasn't been doing that in the physical world, but I think it's just a matter of time. I've actually been out of the DeepRacer League kind of stuff through COVID, and I'm just now getting back into it. So, as things are loosening up, I'm hoping to get our own meetup back together and to start racing. We just built the track at our last meeting before everything got shut down. So we never actually got to do any racing on the track. So looking forward to doing that soon.
Okay. My other idea again about smoothness was, I'm not sure if the DeepRacer could handle the weight, but putting a soda can on the DeepRacer, and then again, if your car was jiggling, you'd shake up the soda can, and at the end of the race, you had to pop the top next to your head.
Well, it can handle a fair amount of weight. I have not actually weighed everything that I put on top of the car. It is making the suspension sag. And then I found out that the company that makes the cars has a mod kit where you can replace everything on the car that's plastic with anodized aluminum. And they have upgraded shocks, but I think they're upgraded dampening capability, not total weight carrying capacity. But you could put little shims in, like you pull the spring down and put a shim in, and that would increase the downforce. So I think you have a little bit of room to play, but they don't seem to make, that I've found, adjustable shock absorbers.
Hey, Chris, pretty awesome talk, by the way.
Thank you.
Did you have any issue with the camera because of the weight of the blaster jarring the camera as you're driving? Did it affect?
I don't know yet.
Okay.
I got everything working with the object detection model. So basically, the way this works is that you build something on top of the platform. So I left all the native capability in there for the car to load a self-driving model and to drive around the track, but it wasn't feasible to set up the track to try to do any driving, nor did I even have the time. I mean, to pull it off in a month, it was crazy. I was just worked at the end of that. So so I don't know. And that's where, I knew, like, hey, the car's sagging. This is going to have clear performance problems going around turns and stuff like that. And so I got it to the state that it's in. And so, eventually there will be a next phase, or, the community can jump in and make contributions and take it from the place where I left off. Yeah, I think anytime you add weight, that's going to be a problem. I mean, look in auto racing, right? It's all about, like, where can I trim weight out from it? How is that going to change the center of gravity and everything? So I think it's obvious. I'm glad you brought it up, but I think it's an obvious thing that it's going to impact in some way. I don't know that, I haven't dug into the code in terms of when the car is driving, the height of the camera, how much is that going to impact it? Is most of what it's doing left and right, you know, in terms of just steering the car, or is part of the code looking at distance, right? Because if you push the front of the car down, then it's going to make it look like things are closer. I'm just not sure how it would impact that. But yeah, it very well could.
Okay.
So Chris got another crazy idea. You know, this one might take you as much as 3 days to do. So I'm thinking an outdoor squirrel chaser. So because squirrels just decimated my pear trees, and it's war, and I'm obviously losing. So replace the wheels with bigger wheels to be able to go outside. Add battery, which is a weight trade-off, but a model that would recognize squirrels and just chase them.
Well, to your point, think about it this way. If you had an industrial use case for this in which a toy, four-wheel drive truck was not the ideal physical platform, there's no reason why you couldn't take the compute node or to load the code on something similar, right? Because they've open sourced, I think most of it, and then put it on a more industrial framework, right? Because you have steering control and you have throttle control. So that those are known quantities, and this is all just using off-the-shelf RC control stuff. So you could definitely build something bigger. In fact, someone built a go-kart using the DeepBlaster technology, and they've made a self-driving gasoline-powered go-kart. And they're in the DeepBlaster community. So I don't know if they took the compute node off of their DeepBlaster, if they used Raspberry Pi or something. But that's certainly possible. Of course, there's the 800-pound gorilla of the ethical use of AI, and we keep crossing this. I mean, even with a toy blaster, there were certain words that I was recommended not to use in relation to talking about what is it to me a tongue-in-cheek kind of a gamification, but you wouldn't want to hurt any animals or be known for that, would you, Brian?
Well, I used to be an animal trainer, but squirrels, they cross the line, man.
I have dents in the roof of my car from the squirrels going up the acorn trees in my neighborhood and just dropping them on the top of the car every November.
Yes, my next iteration was going to be putting electric fencing in my pear tree branches. So,
Brian,
yeah,
you need to be careful. Squirrels can be pretty smart when you've been exposed to some training models themselves, and you could start yourself an arms war, and you never know who might win in the end. So be careful what you start.
Yeah.
Look online. There's a guy who was at war with squirrels, and he set up an obstacle course.
Yeah.
And they figured it out. So now, if we flip the problem, what if you created an AI to train the squirrels to not do the things that annoyed you?
Right.
Now that would be an ethical use of AI, right?
Well, the thing is, one of our neighbors actually had the thing of, you put a clamshell, a clear plastic clamshell around the pear so that they can't get it. And what did the damn squirrel do? Shoot off the whole damn branch and drug the branch off. And then the bunch of them, it's like, okay, I'm losing, but so anyway, and to somebody's point, I don't want to build this. I want you to build it, and I want to buy it.
Well, so the Poopinator idea during the kind of peak of COVID, we were working on a PPE detector that was a Raspberry Pi with a camera built into it that you would basically attach to the entrance of an office. And then if you wanted to come in, it wouldn't let you in the door unless you were wearing a face mask and wearing it properly, because a lot of people wear the mask under their nose and whatnot. So you would have to have a properly affixed mask to do that. And then I have a boat, and one of the problems with boats is that birds like to perch on them, and they just go everywhere. So they have these plastic owls that you can put out there, but you know, the birds are smart and they kind of know, well, if the owl doesn't move around, it's probably not an owl. So I thought I could put a Raspberry Pi with a camera with a bird detection model and then have servo controlled wings that would get the owl to move, and the birds don't like random movement like that. And and I may still build that because I'm going to move my boat down here to Santa Cruz, and it's really bad down here with the birds. So I'm going to need to do something.
You could just get one of those fish that talk that mount on the wall. You'd have a motion sensor. But anyone with a more legitimate question, I can keep going.
Yeah, Brian, I was going to go off on a tangent and say I can volunteer the owls, the baby owls that are growing up next to my house. They're pretty effective at squirrel maintenance.
And you know, if they stay on my boat.
Hey, Chris, when you're building this, do you have any issues with the compute module and performance, adding the added like Arduino communication? Like how maxed out are the resources on this DeepBlaster?
So if you're going to run multiple object detection models, I'd recommend the neural compute stick. And the location that I put it in, it seems to be completely designed for that compute. It fits like a glove, like they made it that way. And it was recommended in the open source documents. So it does fine without neural compute stick doing standard DeepBlaster stuff. But if you're going to run multiple models, I'd say it's a must. And they're not very expensive. They're like another $80 to add to the cost. The node, the compute node is like a 2 processor node, and I don't think it has a GPU on board. It might. You know, if you think of like NVIDIA Jetson Nano, you know, has an onboard GPU. Raspberry Pis do not, and a GPU is better at doing inferencing than a CPU, but it's not as good as these, you know, custom-made silicon like the Intel Neural Compute Stick, the Google Coral, and so forth. And so it really offloads that off of the processor. And then when you're working in ROS 2, you know, the more nodes you build, well, the more demand you're putting on the 2-core processor or whatever number of threads it's able to execute. And so, yeah, I think it's a no-brainer to use one when you can.
I just mean, did you run into any issues or constraints on the actual DeepBlaster chip or board itself?
No, I crashed it a couple of times doing stupid things. You know, I think I had a loop with the serial port trying to open it or something, and it literally crashed the computer. But otherwise, I mean, you know, it's not going to be as fast as your Mac or your PC. So you're working with limited resources, and the object detection model is based off the MobileNet framework. So whereas stuff like MXNet is like produces way too heavyweight models, I found that with the deep lens. So yeah, you have to take that approach. Like, think when you had to boot a system off a floppy and you had 512 bytes to put your bootloader stuff in there. You know, make it as lean as you can to honor what little resources you have. If you do that, I think you'll be okay.
Cool.
Well, if there are no other questions, I want to thank Chris. This was a different kind of talk for us, but fascinating. I want to thank our Boston community and our Indy community. And I had a thought about, this is a different kind of talk. And I will say at Alexa Live yesterday, there was a company that Alexa stop. At Amanda Live, there's a company that makes replacement gas stove knobs that would turn, you know, control the temperature of your gas stove, would let you, you know, safely turn it off on a timer and stuff like that. And I'm intrigued by the notion of like just something the size of a gas stove handle that would have battery and sensors and Wi-Fi and motors and all kinds of crazy stuff. So we may, you know, bring a few more sort of maker kind of things into our various meetings. So, Mary Beth or Laura, any closing word?
No, thanks for having us, and hopefully we can do another joint meetup again soon. Be fun.
Yeah,
Okay,
absolutely.
great. Hey, Brian, I'm just noticing there's some questions in chat that I didn't get a chance to ask. If you would send me the transcript, maybe I can answer some questions and send them back out.
Absolutely. And the first thing I'm going to do is save the chat. Save the chat.
Oh, I can do that too. Okay, I have a copy of it. So,
Okay.
yeah, great. All right. Well,
Okay,
thank you
awesome.
everybody for having me. I appreciate the opportunity, and I look forward to connecting with you on LinkedIn if you want to.
Okay, and we'll post the recording once my computer has chewed on it. All right.
All right.
Thanks all.
Bye, everybody.
Thanks, everyone.